So we have seen what is data science, what is AI, and what is the difference between machine learning, deep learning, and how it is correlated to each other. And we also seen this data science lifecycle. So we start with business problem. We collect the data based on the problem we are facing, and we clean our data and prepare for the EDA part. And in EDA part, we do different insights. We found some inferences and we found some analysis from the data itself. And then after we go to feature engineering, means we try to discard the feature which are not important, or we try to find which feature are more important and more valuable to predict our result. Okay, so that's called feature engineering. And then after we feed our data to our machine learning model, and in this part we try to find the best model or best algorithm which will do our prediction. And thereafter we go to model evaluation. We try to test our model which we has finalized in the machine learning part. And then after we try to visualize all our data in data visualization part, and then we deliver to our client with some hosting, okay, whether cloud or something else. And we also seen what is data analyst, ML engineer, and data scientist position, and how they are different and correlated to each other. So today we're going to talk about the NumPy. Okay, so I will start from the NumPy. Okay, so let's start our session today. So what is NumPy? Basically, it is a numerical Python. Okay, so what is NumPy? NumPy is a Python library. So it is a library which is work on arrays. Okay, so for example, in Python we have the concept of list. Okay, but list is different from the NumPy arrays. So how it is different? The lists are very much slower than the NumPy arrays. Okay, so when we work on the data science things, right, so we need computation power, right, we need more optimization, data structure kind of thing. So that we use NumPy arrays. Okay, so for more advanced mathematical function we can say, so for example, let's say linear algebra, Fourier transformation, matrix multiplication, and n number of mathematical problem we face in the machine learning problem, right? So on that we try to use NumPy data structure. Okay, so yeah, it is a history. It was created on 2005 by Travis. Okay, now it is free, and it stands for numerical Python, as I already said. So why use Python? So simple. We have list that serve several purposes of array. Okay, so in Python normally we use direct list. Okay, we don't use array. So those who have learned Python, they know there is no concept of array in normal list. We in Python, right? We just use list and try to do everything from the list itself. Okay, but they are very slow to process. Okay, so NumPy aims to provide an array object that is up to 50 times faster than traditional list. Okay, let me zoom more. Okay. Okay, so basically, as you can see here, it is 50 times faster than the traditional Python list. So we can see if the data is very large in machine learning model, we have many data and many numerical data which are so much large, right? So we need more quick computation power so that we can use NumPy here. And the array object is called ND array. So ND means number of dimension. So there can be 1D array, 1 dimension, 2 dimension, 3 dimension. Okay, so ND array. Okay, and yeah, they are frequently used in data science where speed and resource are very much important. And we can see here why NumPy is faster than the list. Okay, because the NumPy stored at one continuous place in memory. Okay, list doesn't do like this. In list we can append at any point of time. So for example, I have 5 items in the list. Okay, so I can just do list dot append and add a number. If there is 5, then it can up to 6. Okay, so 6, 7, 8. So it dynamic, you can say. Okay, but NumPy is not such like that. It store in a continuous memory location, so it can access and manipulate them very efficiently. Okay, so so as in computer science, we know the concept of reference. Okay, pass by value, pass by reference. If you don't know, then we don't need to bother about that. Okay, right now okay, so this is the main reason why NumPy is faster than list. Okay, and it is more optimized. and also it is optimized to work with latest CPU architecture. So that's the basic theory of NumPy and why you use and what it is. Now we'll start with our some practical. First, I will let you know the concept of this NumPy array, and then once I complete one part, then I will let you to do the hands-on practice for this. Okay, I will share with the in the Google Drive, and you can download the file from there, and you'll do some practical uh, at the same time. Okay, so hmm, okay, so for for importing NumPy, there is package called NumPy, import NumPy, okay, as np. So this is nothing, just like alias. If you are familiar with Python, it's not much things here. Okay, so np is the name right now. So what we do, np dot array. So this is the syntax, curly braces, and within that we pass list. Okay, so this is basically a list. Okay, in the square bracket. So 1 2 3, I have passed a number. So let's execute this one. So we can say here the array is defined array of 1 2 3 elements. Okay, let's pass into the one variable. Okay, and we print this variable. Okay, now in Jupyter notebook, if you pass some variable, some value in the variable or x, and you directly write x and enter. For those who are new in Jupyter notebook, for those who know, that's fine. So some guys are new in Jupyter notebook, so I'm telling them. So if you do simple this print x, it's printing directly the array itself. Or we can do print also statement. We can give print statement. Okay, we can do this also. In this case, it will not show array, the data type, which data set type it is. Okay, it just print the content of that array. Okay, it looks like list right now when we printing, but it's not a list, it's a array. So for that you can do this, you can use type. Okay, for type x. So what is the type of x? Here you can see numpy and the array. Okay, or if you do exactly list 1 2 3. Okay, and if you try to print the type of x1, then it is list. Okay, so that's a difference. X1. Okay, so see x1 I have assigned just a list only, so it is a type of list. Okay, and x, it is a np dot array, so that's why it will show the numpy dot nd array. Okay, so that's how we initialize or how we create a numpy array in Python. Now yeah, this is a two key difference between list and Python, list and numpy array. Okay, so in numpy array it is stored the same type of data. So what does that mean? So let's say for example, I have 1 2 3 4 and some string over here abc. This is our list. Okay, and when I print this x, now you can see here this data 1, this integer, this is also integer, this is also integer, only this part is string. Okay, but let's pass this in the numpy array. So np dot array. Okay, now see what we see. Now all the data like 1 2 3, it also converted into string. Okay, so basically in list there is a heterogeneous collection. So list can be on so string can be there, the integer can be there. Okay, but in array, whether it is a whole integer or whether it is a whole, all of them will be a string. That's simple. And what yours we see here is d type means data type, and u11 means unicode 11 means the string unicode 11 means the total number of length of the particular string will be less than equal to 11. It will not more than 11. Okay, so default it is so default minimum it is 11. So let's say I type longest integer more than 11. Now what the numpy array will do, it will do some length. Okay, so based on this length of the string we are passing, the numpy array default the upper value some calculation. do some calculation and define the upper value for that string. Okay, so it's based on what we type over here. Okay, so for ABC, so minimum is Unicode 11. So whenever you see D type some U and number, and it is basically a string type data type. Okay, so if I try to assign in x2, okay, and try to print the type, okay, type of x1, x0. So you see string, we have passed integer, but it's converted to string. That's because one of the element in the array is list. So string is the dominator. Okay, let's say I passed over here floating value 5.8. Okay, and print x2. Okay, see, all the data is on floating point. Now the floating point is dominator. Okay, and you can see type of x2 or 0 index is float, right? So that's the difference between list and numpy arrays. Okay, so list can be homogeneous or heterogeneous. And also we have seen this lists are not optimized for numerical computation and have slower mathematical operation. Okay, so yeah, that's the difference between numpy and array and list, Python list normal. Okay, so these are, I have already shown to you. So one is integer, two are integer, and one is string. Okay, so it's converted into all the data converted to string. Okay, now here you can see some of the example. So here the one data is floating point. Okay, and here all the data are string, integer, and here two data are integer, one is string and one is floating point. Now we are printing here type of x0 means this element, and we are trying to print the type of this element and here this element. Okay, now see what we can see here. When you execute this one, see the first element is float. Okay, because here the floating 3.0 is the dominator. Okay, and here it is integer type. Okay, because all are integer, and here the string will be always dominating floating point as well as integer value. Okay, so now it is a str type, and we are printing the whole x1 x2 over there, and you can see it is a point. Yeah, it's pretty much simple. Yeah, and we can check over like this also, it's nothing else. Okay, so uh, so till now it's clear, or anything you have doubt in this, in numpy array and list? If it's clear, then just ping clear in the chat so I can proceed further. Okay, so I assume there is no doubt about this, so I will proceed further. Okay, so next is numpy dot as array. Okay, now what is as array? So we have seen array. What does array do? Np dot array, numpy dot array. It will create the numpy array of this list, right? Now what is as array? So as array is also same thing, just like array. Okay, so array also convert any list to numpy array. As array also convert the normal any list into the numpy array. But the key difference is here. I will show with you one example. Let's say, for example, I have this 1 2 3 and I am creating original ARR, original array. Okay, so I have assigned in the original array. Now let's say I am doing numpy array with this original array, right, and assigning to new array. Now let's say this is our new array. Now in the original array, I am replacing this 0th index value with 6. okay, an original array, and trying to see if there is any changes in this new array or not. Okay, so let's see. So we can see for new array it is the value is intact. Okay, no changes. That's because then np.array. Okay, so this np.array creates the new copy of the array which is given in the parameter. Okay, so there is a new copy of this that original array. That's there is not a same reference to the original array. But on the other hand, if we pass any array in the as array, okay, so just like if you are good with Python, then we know the concept of copy deep copy, right? So what the copy and deep copy do is like it create the new copy so that the array when the changing in the original array, it will not impact in the new array. Okay, so same thing is here. So the np.array creates the whole new copy in the new memory location. Okay, but let's say I am doing same thing with this. I have new array with a value of 1, 2, and 3. Okay, so a value of 1, 2, and 3. Now, if I assign to original array the 0th index with 6 updating value, right? Now, if I execute this one, now you can see the new array also get changed, right? Now I can see 6 over here because I have changed in the original array. So you can see over there, as array is not creating the new copy of the array. Okay, it will keep on referencing the same copy, same original array which it is passed in the parameter. Okay, so that's the key difference between array and numpy array. It depends on the situation and the requirement you need during the code. So what if you want the same reference with the same array, right? So we can use as array. Okay, so changing in one array will be also get impact to the new array. If you want the whole new data with new array, then you can use np.array. It's just the normal one key difference between array and as array, nothing else. Okay, so yeah, this is already I have explained you type and the array. Okay, this is also clear. Okay, so before moving forward, so just do some few hands-on. I will share the link and then we start with another part. So just open this link, Google Drive link. Okay, in this folder you will get this numpy1 numpy_1 dot Python notebook. Okay, and those who have installed yesterday, just try to open this numpy file. Okay, so if you are having issue, then just ping me, I will help you out. And those who are familiar with Jupyter notebook, so they can easily open this Python notebook. So how many of you have just installed yesterday? Okay, so as that is completed, so here are a few feature of numpy array. So basically this is 2D array, right? So in this 2D list, it is actually 2D list. Okay, so 1 2 3 4 5 6 7 8 9, and this my mat is passed in the numpy dot array, and this mat is now a 2D array. Okay, now I have printed over here what is the type of this MAT, and here it is printed out the NumPy array. Okay, and here I have printed the matrix, so the 2D array is here. And what is n dim? So n dim is the, it gives the dimension. Okay, so 2 dimension, 3 dimension, something like that. Okay, so mat dot n dim, so it's giving dimension of this matrix to 2D. And what is the size? Size is 9, so number of elements over here. Okay, pretty much simple. And what is shape? Okay, 3x3, 3 by 3. Clear. And what is the data type? It is the integer data type. Okay, so there's a few things you need to know. Now come to arrange and linspace. Now what is arrange? So in list Python, so we have, not in list, sorry, in Python we have range function, right? When we try to use loop for I in range, okay, 1 to 10, 5 to 10, something like that. So what does range do? It gives the number from 1 to 10. So if I say range 1 to 10, so it gives 1 2 3 4 5 6 7 8 9. Now same thing is done by the arrange also. Okay, nothing different. But what is the difference between arrange and range? It's just on the basic of speed. Okay, when we try to use arrange, for example, if you're looping through arrange or doing something computation power with range, like from 1 to 10,000, let's say, for example, it is fast than range. That's a simple thing. So whenever there is a concept of numpy, anything inside the numpy is there, then just be sure about that. If the numpy has a speed over the normal function of the Python. Okay, so that's why. So we use arrange in data science many times. Okay, so for example, you can say np dot arrange 5 to 16. Okay, now I have done what is the type of this. So you can see here the type of this is numpy dot array. Okay, and when there is numpy dot array, then it means it is fast. That's the only concept over here. Okay, so it's similar that of range, nothing new. Same 5 to 16 with 2 space. Okay, so 5 to 16 means 16 minus 1 till 15. So 5 7 9 11 13 15. Pretty much simple. Okay, and yeah, this is the range function that I am talking about in the Python. So I think everyone is familiar with Python, so no need to explain this one. Okay, now yeah, there is one new concept. It's not in the Python, it's only the in NumPy. So it's lens space. So it's called basically the linear space. Okay, so what the linear space is basically, so let's say for example, I from 1 to 10, I need four numbers from 1 to 10. Okay, but the difference between each number should be same, with same difference. So in that case, what will be the number? So we start with 1. So it 1 and 10 both are included. Okay, so it's not between 1 and 10, it's from 1 to 10. Okay, so first element will be 1, second will be 4, difference is 3, and third element will be 7, difference is 3, fourth element would be 10, difference is 3. Okay, so 1 4 7 10, evenly spaced. Okay, so linear space means we try to find the number of items from the range between start to end, number of elements, but with same difference. Okay, so we have a concept of AP in mathematics, arithmetic progression, right? So we have a difference D, right? So A2 minus A1, right? So element second minus 1, element third minus second. So difference is D, we can say. So that is same concept in linear space if you want to create something like that. Okay, so let's remove this one. Okay, so here, for example, let's say I need 50 elements from 1 to 10. Okay, but it is should be linearly spaced. Okay, so same space between each element. Okay, so if I execute this one, 1.1873, anything else, okay, something, and 1.3. So if I try to minus this with this, minus, I get 1.3678. Okay, so the difference between this and this also same, 1.18. Okay, 18367, something like that. Okay, so that's a very basic concept we try to know. So yeah, so if based on requirement, so I have not used this much. I don't think it is required many times in our data science concept, but yeah, maybe sometime we need to create some dummy data, for in that case we can create this. Okay, so first element is start, that is ending, and that is number of elements we want. Or we can say, for example, let's say I need a table of 2. Okay, so I can see that. Okay, 2 into 1 2 2 2 4 2 3 into 2 3 6 2 4 8 2 5 10. So multiplication of 2. Okay, so starting from 2 to 10, 2 to 20, because we know each is in a space will be 2 only. Okay, multiple space, and 10 elements will be there. Something like that, we can create our own scenario based on requirement. Okay, so that's a linear space. Now, yeah, matrix creation. So if we want to create matrix of default 0 0 0 0, so we can, there is np dot 0. Okay, and so why these are we are going through, because many times in like AI or deep learning, we need to create some mathematical matrices. Okay, so instead of creating using normal list or normal Python functions, right? We can directly use NumPy here. Okay, because first point, it is very fast and speed, right? And second, it is very quick, so we don't need to do our own some looping or something like concept. Okay, so we directly write np.05, so 5 array. We can also achieve using list, right? So we can create list of 0 into 5 times, right? But list is not so fast. Right now it is like only 5 elements. For example, let's say when we work on the images, right? So there are RGB colors, matrix of different dimension, right? And let's say the matrix will be huge, 1 lakh, let's say, for example. On that case, there was a huge optimization, right? So that's the point. And we can also create 2D. So numpy np dot zeros, 3 cross 4 matrix we can create. It's simple. And np dot ones. Okay, so once is like create 1. And we know identity matrix in mathematics we have already seen in our high school, right? So identity matrix is the diagonal will be 1 1 1 1 1. So we can also create identity matrix. So if we need to need matrix multiplication with identity matrix, so we can do. Okay, yeah, and this is also completed. This is also I have discussed arrange. Okay, so arrange is from 0 to 3. So 0 1 2, simple. Floating point also, point 1. Okay, 0 point 1 point 2 point. Okay, and this is also same thing. This is linearly spaced from 2 to 3. I need 5 elements. Okay, with same space. So see, zero point 0.5 difference, zero point 0.5 difference, zero point 0.5 difference, 0.5 difference. Okay, yeah. So I think it's clear. Okay, can confirm if you need anything else. If you have any doubt, then just ping me in the chat. Okay, so I assume it's clear. Yeah, now the concept of reshaping. Okay, so yeah, this is important because in the machine learning also we need the reshape concept many times. Okay, because when we feed our data in the machine learning model many times, we need to reshape, because the parameter they have created many times is sometimes 2D, sometimes 3D, sometimes 1D. Okay, so based on requirement, we need to reshape. Okay, so let's see what is reshape. So I have created here one numpy array. Okay, so 1 to 9. So total 9 elements are here. Okay, now array dot reshape. This is the method name, or we can say function name. So I pass the number of parameter that is 3 cross 3. Okay, so I need 3 cross 3 matrix. Okay, now this is new array, and I try to print this new array and with new array number of dimension. So if I execute this one, so I can see and time is 2 dimension and but if you pass if you try to pass, let's say 3 cross 4, it will give me error. That's because we have only 9 elements and it is not possible to create 3 cross 4 because 3 into 4 12. So we need more elements over here. Okay, okay, so for 3 cross 4 we need more elements, so that's why we can create. Okay, so yeah, the reshape is clear, I think so. And yes, so we can there is two ways. So we can directly pass number, or we can pass those number in the bracket, or many code you can see something like this also, something like this also. So there is no need to confuse about that. We can directly pass with within a bracket or without bracket. Okay, so that's the difference. Yeah. And what is -1? Okay, yeah. So let's say we got to first. Yeah. So currently my array is this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now when I do uh, -1. Okay. Okay. So right here there is no difference. You cannot see the difference. Okay. That's because the there's only so let me explain what it is doing. So for example, let's say I have 9 elements over here. Okay. So first I have passed. I need 3 row. Right. Now, what does -1 means? There is no parameter. -1 means no parameter. I am not giving any divide that I need to convert it into 3 cross 4 or 3 cross 2 or 3 cross x. -1 means nothing. Okay. So the reshape method itself try to identify what number should I provide here. Okay. So let's say I have provide only the row 3. Now here are 9 elements. So what should be the parameter over here to complete this element? 3 into 3, 9, right? So 9 divided by 3. So the Python will, this reshape will automatically convert this minus into 3. Okay, and create 3 cross 3 matrix. Okay, so let's say for example here I have not passed anything. -1 I have passed. If I pass 3, then also it will create 3 cross 3. But if I don't pass -1, then it will automatically give me the uh, 3 cross 3. So let's say for example I have over here 10, 11, 12. Okay, so I passed over here 3 cross 4. Let's say I didn't pass anything over here, or -1 only. -1 nothing, so it automatically create 4. I don't need to pass this 4. The reshape will automatically detect that 3 into 4 is 12. Okay. Okay, so yeah, which one reshape? So this -1 or normal reshape? Yeah, I think Yuvraj, you are clear now, the reshape thing. So basically reshape is nothing. It just tried. So for example, right now array is of 1 dimension in one shape, right? 1D array, 1 dimension. If I need to convert this into 2 dimension, okay, so there will be rows and column. Okay, now what is the number of rows? 3. What is the number